Will AI replace DevOps engineer? AI can already write scripts, generate Terraform, analyze logs, and even help troubleshoot Kubernetes. Hello everyone, in this video we'll understand how AI is changing DevOps and will it actually replace DevOps engineer. So this is the typical journey of an application from a developer writing code through CI/CD into the cloud and running on Kubernetes and finally reaching into production. And AI is now becoming part of this entire journey. So the question is, do we still need DevOps engineer? Let's find out. Before we answer that question, let's first understand what a DevOps engineer actually does. Let's say a developer writes some code and pushes into Git. From there, DevOps process begins. We need to build the application, run test and create a container image and deploy it. That application might eventually run on Kubernetes and compute platform in the cloud. And once it's running in production, we also need monitoring. So DevOps is not just about deploying code, it involves automation, infrastructure, cloud development, monitoring, troubleshooting, and keeping application reliable in production. Now let's bring AI into this picture. AI can already help with many of the tasks that DevOps engineers perform every day. For example, AI can generate scripts, it can generate Terraform and other infrastructure as code, it can help create Kubernetes configuration. It can analyze logs and explain errors. It can also help with troubleshooting and documentation. So yes, AI is already automating major parts of DevOps. Imagine a developer pushes new code to GitHub. Normally our CI/CD pipeline will build the application, run test and eventually deploy it. Now imagine if the pipeline fails. Instead of an engineer manually going through 100 or 1000 lines of logs, AI can help analyze those logs and identify what might be the issue. It can explain the error and suggest a possible fix, and in some scenario even generate the change required to fix it. This can save engineer a significant amount of time. But here's a catch. AI can suggest the solution, but the engineer still needs to validate whether that solution is safe to deploy in production or not. Now let's take another very common DevOps problem, that is Kubernetes troubleshooting. Imagine your application is running inside a Kubernetes cluster and pod status is running. Suddenly your pod starts failing. You might see something like crash loop backoff. Traditionally, an engineer would start checking the pod status, application logs, Kubernetes events, configuration, resource limits, and dependency. And sometimes finding the actual root cause can take quite a bit of time. This is another area where AI can help. Instead of manually going through all these signals, we can provide the relevant logs and Kubernetes events to an AI assistant. We can simply ask, hey, why did my pod fail? AI can analyze the available information and suggest possible root causes. For example, it might identify incorrect container image, configuration problem, or maybe insufficient memory, or an issue with another dependency. This can dramatically reduce the time required for initial troubleshooting. But again, there's an important limitation of an AI. AI can suggest a possible root cause, but it does not automatically understand the complete context of your production environment. So you have to be very cautious. Now let's move from troubleshooting to infrastructure provisioning. Suppose we need to create a cloud infrastructure. So instead of writing every Terraform resource manually, we can ask AI to generate the Terraform code for us. It can generate resource, variable, modules, and even help us to understand existing Terraform code. Once code is ready, we can plan and apply and deploy it into the cloud. This can make infrastructure development much more faster. But here's where we need to be very careful. AI generated Terraform does not automatically mean production ready infrastructure. We still need an engineer to review networking, IAM, security, high availability, cost, compliance, and disaster recovery. Because a small mistake in infrastructure code can have a very large impact in production. Let's look at observability now. Modern applications generate huge amount of log, metrics, and traces. Traditionally, engineers would look at these signals, investigate alerts, and try to identify the root cause. But when you have hundred or thousand of alerts, doing this manually becomes extremely difficult. AI can help correlate these signals and identify patterns. For example, it might notice that application latency increased shortly after a deployment, or it might identify the several services are failing because they share the same underlying dependency. This is where AIOps or AI for IT operations becomes very useful. Instead of simply giving engineers more alert, AI can help reduce the noise, identifying patterns and suggest possible root cause. So now we came to the most important part of this video. We have seen that AI can write scripts, it can generate Terraform, it can analyze logs, it can help troubleshoot Kubernetes, it can even help us to understand operational problems. But there are certain things that AI cannot simply take over. First one is architecture. In architecture, suppose how should we design the system that AI can't replace. We have to be very cautious while designing the system. Second one is security. How do we protect our application and data? The third one is trade-offs. Should we optimize for cost, performance, availability or something else? The fourth one is business decisions. Does this architecture actually make sense for this business? And finally, the accountability. If something goes wrong in production, someone still needs to own that decision. So I don't think the DevOps engineer is disappearing. I think the role is changing. In the traditional DevOps model, engineers spent a lot of time on manual deployment, writing scripts, troubleshoot issues, managing infrastructure, and responding to alerts. AI can automate or assist with many of these repetitive activities, and that allows engineers to spend more time on higher value activities. Things like platform engineering, cloud architecture, security, reliability, and automation. So instead of thinking about AI as replacing DevOps, think of it as moving DevOps from version 1.0 to version 2.0. Now the question is, what does the DevOps engineer of the future actually look like? Strong cloud fundamentals will still matter. Kubernetes, yes, still matter. Infrastructure as code will still matter. But now we also need to understand AI and AI ops. And most importantly, we need to strengthen our architecture and system design skills. Because the value of an engineer is not just in how much code they can write, it's in how well they can design, secure, operate, and improve systems. Remember, we don't have to compete with AI, learn to work with it. Now, coming back to the original question, will AI replace DevOps engineer? No, not exactly. AI will definitely automate many repetitive DevOps tasks, but that doesn't mean the engineer disappears. In fact, I believe the opposite. DevOps engineer who knows how to use AI effectively will become more valuable because instead of spending most of their time on repetitive tasks, they can focus more on architecture, reliability, security, automation, and solving complex business problems. And that's where I believe the future of DevOps is heading. Thank you so much for watching. Don't forget to like this video, comment your feedback or suggestions below, and subscribe for more content. Till then, stay curious and keep learning.